This presentation is about use of self-marking electronic quizzes by South African learners in impoverished communities to learn science better. 80% of South African learners are classed as poor and attend severely underperforming schools. From 2013 to 2018, I worked as a mentor to help teachers working in these kinds of schools. I did this within the University of the Free State's Social Responsibilities Project. The University of the Free State is situated in Bloemfontein, which is in the center of South Africa, and I would travel daily to the township of Botshabelo, where I worked in 5 underperforming schools in these very poor areas. It's known that extending learning time and providing rapid individual feedback can enhance learning, and electronic quizzes are well suited to serving each of these functions. In all the schools, I found donated computers and tablets, but they were locked up and they weren't used. So I loaded software that I had created onto these devices, and I taught the learners and I taught the teachers how to use them. The software that I loaded, it's curriculum aligned and it includes electronic quizzes. I made the quizzes with hot potatoes freeware, and there are different kinds of these quizzes. They're match quizzes, and they tend to be relatively quick and easy to do, and they focus on the meanings of terms. And then they're gap-fill quizzes, and they tend to be more language demanding, although I provided guidance by giving drop-down lists. And then there are also multiple choice quizzes, and they also tend to be relatively language demanding. For all the types of quizzes, after you've answered the quiz, then you press a check button and then it gives you immediate feedback, giving you the time, the score, and maybe even some hints of how to improve. And then the learners are required to correct incorrect answers before they go on. For use of ICTs to be effective, you need to use them actively, intentionally, and constructively. When you engage in an electronic quiz, you have to input answers, and so the user has to be at least behaviorally active. Intentional learning refers to learning with purpose. That's particularly important in electronic quiz engagement because people can try to game the system, and that means guessing or random button pressing to try to advance in the quiz without having to undergo the thinking that's required. Constructive learning means engaging in sense-making during learning. Generally, the purpose of the match quizzes is to develop the appropriate vocabulary to enable the learners to then go on and make sense of the concepts as they work through the more language-demanding gap-fill and multiple-choice quizzes. In order for these electronic quizzes to extend learning time without providing additional burden to the teachers, I tried to arrange that the learners could work on the software out of school time, unsupervised. And that meant that the learners were free to decide which quizzes to engage in and which ones to skip. So the question I was really interested in answering in this research is, would learners like these, who have poor educational foundations due to their poverty, would they be able to use these quizzes intentionally and constructively so that they would actually benefit from the quizzes? I particularly want to focus on intentionality because it's closely related to the very powerful concept of motivation. Because in both cases, it has to do with the reason why people make certain choices. So, to reword my question, would learners such as these display autonomous motivation to self-direct their learning by making choices about which quizzes to engage in and which to skip and whether to persevere or whether to give up? And would they do this in a manner that leads to meaningful learning? I ran a 7-week intervention involving learners from 2 of the schools where I was working in. The learners were chosen by their teachers as being the highest achieving learners in their class, so the sample is relatively academically strong for the context. However, as I'll show shortly, the sample had a wide range, and a large fraction of them are weak in absolute terms. During the intervention time, the learners were given at least 1 hour's access to computers at their school, loaded with these electronic quizzes after school hours. They were told to work through as many of the energy and change quizzes as they could to help them learn the topic well. English is not the home language of any of these learners, but it is the language of learning and teaching, and all the quizzes were in English. They've all grown up in extreme poverty, and the education that they've received has been shown by international benchmarking tests such as TIMSS to be amongst the worst in the world. This is the house of one of the learners in the sample to show the extent of the poverty of many of these learners. Each child was given an engagement diary like this one and was told to fill this in for each quiz that they completed. On completion, the software reveals a score and a time, and so the learners had to take that information and then transcribe it into the relevant part of this engagement diary. At the end of the 7-week intervention, 29 of the grade 8s in this intervention submitted their completed diaries, and these are the learners who were admitted into the sample for this research. They and their parents also gave informed written consent for this inclusion in the study. All the learners wrote a common test at the end of the intervention period. I used the learners' marks in this common test to classify these 29 learners into 3 achievement categories as indicated here. I had also administered pre- and post-tests at the start and at the end of the intervention for a related research project. These particular mark ranges were used because they resulted in almost equal sizes of each of the groups. Notice that the 3 groups did not differ much in their means for the pre-test, but they differed greatly in their means for the post-test, showing that the learning that happened between these 2 tests was differentially effective. So that leads us to ask, why? In terms of the conceptual framework used in the study, we can ask whether the differential effectiveness is attributable to different extents of intentionality of engagement related to different types of motivation. In the quest to obtain answers to this issue, I formulated these 2 research questions. The first has to do with the choices the learners made regarding how many and which types of quizzes they engaged with during that 7-week intervention period, and also how long they spent engaging with these quizzes. And I did this comparison between those 3 achievement groups. Here we have the 3 achievement groups: the average number of quizzes recorded, the average score, average time spent per quiz, average total time, and average number of quizzes of each type engaged in. For simplicity, let's only focus on the top and bottom achievement groups. Notice that compared to the lowest group, the highest achieving group did many more quizzes, performed slightly poorer, spent longer per quiz, and much longer in total, and did many more gap fill, which were more language intensive and more focused on sense making. This answers our first research question. Now, in terms of the conceptual framework, how do we explain this? The lower achieving group did easier, quicker quizzes. That's consistent with introjected motivation, where gratification of the ego is the main driver. In contrast, the higher achievers did more difficult sense-making quizzes, which is more time-consuming, and they put a lot of time into engaging with the quizzes in total. That's consistent with autonomous motivation, in which the learner is driven by a desire to learn and make sense of the work. In other words, to be intentional in their learning. This autonomous motivation is further evidenced by these learners being observed to voluntarily copy down notes for themselves at the end of each activity. However, there are a number of limitations arising from the fact that this study relies on self-report data. So to reduce this limitation, I asked this second research question, which related to the learner's usage of 2 quizzes, which differed in language demand while being observed directly using eye tracking equipment. And this part of the research happened a year after the first part. Each of the learners in the sample engaged with the quizzes using eye tracking equipment. Here you can see a learner engaging with such equipment in the calibration phase. And this computer here is fitted with eye tracking capabilities, where the eye tracker videos the screen overlaid with a dot which shows where the learner's eyes were directed at various times across the video. The learners engaged with 2 quizzes. The lower language demand quiz was similar to one that they had been exposed to in my interactions with them as a mentor in their schools. Each of these 7 drop-down lists gives the option less or more. The higher language demand quiz consisted of a text that they were unfamiliar with, followed by multiple choice questions which were designed to test comprehension of the text. I'll first present the data for the lower language demand quiz. For the purposes of this particular study, only the scores obtained and times taken to complete the quiz are plotted here. Each learner is represented by a point, coloured according to their achievement group. For the higher language demand quiz, this is the plot of the score obtained against the time taken to complete the quiz. Here the two graphs are shown next to one another. So what can we see? For the lower language demand quiz, a shorter time to completion tended to be associated with a higher score, whereas it's the opposite with a higher language demand quiz. A longer time to complete tended to be associated with a higher score. And that makes sense, because for the lower language demand quiz, those who engaged intentionally read and understood the quiz quickly, and they provided the answers quickly, because the text was short and the options were few. Whereas those who didn't engage intentionally often didn't even read any text that could be seen by their eye movements using the eye tracker. They simply went straight to the options, guessed anyone in each case, and then they pressed the check button, and then the quiz required them to repeat the process, so then they did that and they continued by trial and error, and all that took quite long, slower than, in this particular case, engaging intentionally took. But in contrast, intentional engagement in the higher demand quiz generally took longer than this kind of guessing process, because it required reading, sense-making, maybe even rereading some parts of this lengthy text. Notice that for the lower language demand quiz graph, there's no obvious difference between the achievement groups in the clustering of the dots. But for the higher language demand quiz, there's a very clear distinction, with the higher achievers clearly more successful than the middle group, than the lowest achieving group. Here I've given the answer to the second research question, which summarizes what I've just been saying. So how can we make sense of this in terms of our conceptual framework? The first thing to notice is that all the learners engaged with the quizzes to a considerable extent, despite them not being forced to do so. In my work in both contexts of poverty and greater affluence, I've often noticed this enhanced eagerness to learn amongst the poor. The significance of this study is particularly in showing that this eagerness to learn can translate in effective learning by the higher achievers. And this is even in the case where there's no or almost no externally provided supervision, monitoring, and motivation. The higher achieving learners in this group clearly had a sufficiently high literacy level to understand the quizzes, and they appear to have been autonomously motivated to engage with the quizzes intentionally. That's significant because it suggests that for this higher achieving segment in contexts of poverty, electronic quizzes can be used effectively to extend learning time and provide rapid individual feedback out of school time without requiring the intervention of a teacher. The limiting factor for such learners is access to such quizzes and to devices which can run these quizzes. So the significance of the study is that it suggests that targeted donation of appropriate hardware and software to higher achieving learners in contexts of poverty can result in enhanced learning. I end this presentation with a clip from one of the learners who benefited from being part of the program run by my university, of which this study forms a part, and he was involved from when he was in grade 6 all the way until grade 12.
I really improved a lot in my physical sciences. I managed to obtain 90s in my physical sciences, so this software really helped me a lot. I don't have a computer at home, so I used two devices. I used my cell phone and also the tablet that I got from Dr. Angela first. And this really helped me a lot because I worked really hard, and I also went to the competitions in when I was doing grade 10. In those competitions, that's whereby I won the tablet. These competitions were the grade 10 Olympiads. Well, with the resources, I worked through them in the December holidays. I worked with them like each and every day. I watched the videos, did the quizzes of physical sciences, and I also did the ones of natural sciences. So after watching these videos, then I did some quizzes in order for me to check if I was really understanding what I've learned from the videos. And then after, I did some simulations for practical activities, and also some other stuff on this software.